Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest 2 2015-2016 Division A. Okay, question 1. Do the diagram to the right, angle ABC is 40 degrees, AB and CD is parallel, and BC and FD is parallel. So these two lines are parallel and these two lines are parallel. Determine the angle of FDE. Since this is 40 degrees, right? That means this is 40 degrees. So FDE would just be, since it's a line, it's just 180 degrees minus the 40 degrees. Is 140 degrees. So that's your answer, 140 degrees. Sorry that I wrote up on it, 140 degrees. Yep, that was question 1. It's just a basic geometry question. Determine the length of a edge of a cube whose numerical value of its volume is equal to the numerical value of the sum of the lengths of the edges. Okay, so it says the volume of a cube is equal to its edge cubed. So basically, it's just, let's say its edge is length x, so its volume is x cubed, which is equal to the sum of the length of the edges. There's 12 edges in the cube, so you have 12 times x as the sum. So subtracting 12x to the other side is equal to 0. Distribute out the x to get x squared minus 12 is equal to 0. So it has to be x is equal to 0, or x squared minus 12 is equal to 0. X can't be equal to 0 because then it's not technically a cube, because it has to be a positive number. So we had to look for this one, which is x squared is minus 12 is equal to 0. So x squared is equal to 12. So x is equal to square root 12, which is just 2 square root 3. So the answer is just 2 square root 3. Okay, question 3. Given that 2x plus 5y is equal to 11 and negative x plus 2y is equal to 7, determine x plus y. Okay, so we have 2x plus 5y is equal to 11. Multiply the second equation by 2 to get negative 2x plus 4y is equal to 14. Now you add them together so it cancels out the x, and you get 9y is equal to 25. So y is equal to 25 over 9. Now you put y back into one of the equations. Let's put it on the second equation, the original second. And then we get negative x is equal to plus 50 over 9 equals 7. So x is equal to minus 63. That's negative 13 over 9. So adding them together, you get 12 over 9, which simplifies to 4 over 3 is your answer. So your answer is 4 over 3. Question 4. A regular polygon has interior angles measuring 168 degrees. How many diagonals does a polygon have? Okay, so if they ever ask for exterior angles, there's always going to be an interior angle. There's always going to be an exterior angle. The exterior angle of a polygon with like this is basically just 180 minus whatever that degree is. So this one is 168. You minus that and it gets 12. So all the exterior angles for a polygon is 12. So the exterior. Does this one give you the interior? But we're gonna work with the exterior because the exterior is easier. There is kind of not really a theorem, but a formula that states that 360 divided by the amount of side lengths, let's say they'll have a polygon with n side lengths, will equal to the angle measure of the exterior, basically. So since our exterior is 12, right? We just need to have 360 divided by 12 now to get the n. So that will be equal to 30, right? So our exterior angle is 30 degrees. I mean, not 30 degrees. Our exterior angle is 12, so we now have 30 side lengths. So since we have 30 side lengths, the 40 sides, the formula for a to calculate the amount of diagonals is just x times x minus 3 divided by 2. So you plug that in, you have 30 times 27 over 2. 30 divided by 2 is 15. So you just have 27 times 15. Okay, so we have 27 times 15. That's 35. That's 3. That's 10, and that's 13. And we have 0, 7, and 2. So this gets up to 5, 0, and 4. So the answer is 405 diagonals. Okay, you just need to know your formulas for number 4. Okay, question 5. Determine angle FDE in the diagram above. Okay, so a trick is that if you have a triangle, right, and you have angle x and y, the exterior angle here is x plus y. Okay, this is a kind of a theorem, so you just have to remember that property. Because this is a straight line and this has add up to 180 degrees, this angle would technically be 180 minus x minus, sorry, minus x minus y, because x plus y plus 180 minus x plus y is 180, so it's all the angle of a triangle, and this is a line, right? So 180 minus x minus y plus x plus y is 180, because the line is 180 degrees. So that's true. So the two angles outside adds up to the exterior angle, which is used here because angle like D plus angle E has to equal angle DFG. So we just need to add them together. So we have 2x minus 14 plus 92 minus x, which gets up to 2x minus x is just x, and negative 14 plus 92 is equal to 78. So you have plus 78. And then that equals to the exterior, which is 3x plus 2. So you minus x to the other side, so you get 2x, and you minus 2x here, so you get 76. So you get 38 is equal to x. And they're looking for angle F D E. So plugging it back into 2x minus 14, you get 76 minus 14 is equal to 62. So the answer for number 5 is 62 degrees. And question 6, a regular polygon is shown in the diagram above. Determine the measure of the angle designated with x. So we have an octagon and some kind of right triangle. So that's what we need to find. Okay, so let's kind of draw this out a little bit. Sorry, my picture is bad. A very bad drawing. And we have something like this-ish. And we have a 90 degrees. So basically, we need to look for x. If you kind of just look here, right? This angle kind of looks exactly the same, which is true because you're splitting it. Because if you just count the thing, you have other than the points where the line goes through, the other points you have 3 points on the right, and you have 3 points on the left. So you know it's gotta be symmetrical. So you know that these both of these angles have to be the same. So x has to be equal to other x that I just labeled. So technically, we just need to find the angle for the interior angle for an octagon. So and like what I used before, since we have 8 side lengths, because we could just work with the exterior and then subtract it from 180 minus exterior to get the interior. So what we would do is that we have 360 degrees, right? And then divide by the side length, which is 8. So that gets 90 and that gets 45. So the outside angle is 45 degrees, right? So the inside angle has to be 180 minus 45. So 180 minus 45, the exterior to get the interior, which is 135 degrees. So the angle measure of a octagon is 135 degrees. If you want to memorize like just like the general like angles for each like shape, like square, triangle, pentagon, hexagon, like you could, but you know this is a fast way to do it. Not a faster way since memorizing is faster, but it's a good way to do if you don't want to memorize. So the interior angle is 145 degrees. This is rectangular. Every single angle is also 145 technically, basically. But we're not gonna focus on that because this is just a right triangle. So we just need to find out since this triangle adds up to 180 degrees, we only need to focus on these two. So we have 145 degrees. I told you that before that these two angles are the same. So just divide by 2. So technically this angle right here is just 145 divided by 2. So since this angle is 90 degrees and this, let's call this x, right? We need to find x. X plus 145 over 2 plus 90 has equal to 180. So x plus 145 over 2 plus the 90 is equal to 180. So kind of subtract those values out and you get the real answer. So x plus 145 over 2 has to equal 90. Sorry, I'm running out of space. Let me move this over, actually. Okay. And I'll rewrite this again, which is equal to 90. And x equals to, what is this? 180 over 2 minus 145 over 2. Get the same denominator. And x is equal to 45 over 2. So x is equal to 45 over 2, which you also write at for number 6. So that's the answer. Or you can write it as 22.5. So your answer for number 6 is like 22.5 degrees. So you just put the degree sign in there. Okay. Question 7. The typical CCML contest starts at 9 a.m. and ends at 9:50. How many minutes after the start times how many minutes after the start time are the minute hand and the hour hand pointing in opposite directions? So they form a right straight angle. So imagine a clock, right? And you start at 9. So you have the minute hand right on the 0 or the 12 uh, or however you call it. And then so we have 12, 3, 9, 6 and 9, right? Because 12 hours, 3 hours, 6 hours, and then you have the other ticks. But I'm not gonna draw because I'm not the best at drawing. And then it says 9, so you have something like here. So your hour hand is right. Oh, a little shorter, right? So this is your hour hand and this is your minute hand. So that's at 9. So when it kind of starts moving, right, and you kind of think about it, then it's gonna have something like right here because the minute hand is moving faster than the hour hand. So it's just gonna move a little, right? Actually, let's move it a little bit more so it's more noticeable. Something like that, right? And then basically, you're gonna have the minute hand all the way on the other side, and it becomes 180 degrees, so it's straight. So basically, 60 minutes in a clock, right? In time. Technically, what I do is I always just count the ticks, like the ticks in here. So it'll be like 12 has at 0 because if you think about it, you have 1, 2, 3, 4, 5, 6. Sorry. But technically, if you think about it, 3 is the 15th tick. Like if you see a clock, like there's just 60 like ticks in a clock, right? I can't draw that much. But basically the idea is that there's 60 ticks uh for 360 degrees because our circle is 360 degrees. So if we're counting the ticks, basically all we need to do is that since there's 60 ticks, we just need half of them. So they need to be they need to be 30 ticks apart from each other. So since we're at 9, right? 9 is at the 45th tick, right? Because 9 is 9, and then every single hour that shows in a clock has just technically 5 ticks away. So technically at 1, you're at 5, and if you're 2, you're at 10, if you're 3, you're 15, and you have 4, you're at 20, right? So it's just 9 times 5, which is 45. So you're starting at 45 as your tick for your hours, and your minute hand is starting at 0, right? And it's moving 1 tick every single at 1 tick at every single minute. So technically, if we add, so if you think about it this way, right? If our hand, the minute hand has to move 60 ticks for it to move 1 hour, right? So if you had to move 60 ticks to move 1 hour is equal to 5 ticks because you had to get from like let's say like 6 a.m. to 7 a.m. Then technically you're just moving 1 hour, but 1 hour is equal to 5 ticks, so that's equal to 5. So technically in 60 minutes, which you move 60 ticks for the minute hand, you have to move 5 ticks for the hour hand. So technically if a minute hand is moving at X amount, right? Then technically we'll just do a proportion, and we have X over 60 is equal to something over Y over 5. So technically what the sorry, I mean just divide by 5 here. So you get 12 ticks equals 1 tick, right? So and every single 12 ticks the minute hand is moving, the hour hand is moving 1 tick. So if you think about it, if our minute hand is moving X ticks per minute, I'm moving like 2 ticks, then technically you just have to like divide by 12 to get the hour hand tick. So the hour hand is just working at 1/12 of X. Because think about it, if you work 60 hours, then you put 60 minutes, and then you put 60 minutes divide by 12, you get 5 ticks, which makes sense. So every single 60 ticks that pass, our hand passed 5 ticks. So the rate of between them is here. So technically, since it starts at 0 and it starts at X and it's going at X, technically you have something that starts right here, and then after that it's gonna move like down here for the minute hand, and it's gonna go like right here, and the hour hand kind of goes up here. It's exaggerated. It's gotta be a little bit, so it's gonna be something like right here, ish, and that's what we need to look for. So in between them, they're supposed to be like as I said before, 30 ticks. So since the X is moving faster, sooner or later it's gonna make that 30 tick. So we just need to have 45 plus 1/12 X minus the X. Because what you're gonna do is like it looks like this. So you're gonna have this, right? As a straight line. So you're gonna have that time. So what it does is that 45 plus 1/2 X basically calculates for this entire thing over here. And then X will calculate all this over here. So then this, the first one minus the second one would just only give you basically this amount. Then this has to be 30 ticks. Right? So we just need to have equals to 30. So now we just minus 30 to the other side, which gets 15. And then this gets negative 11 over 12, which you put on the other side. Right? So then you just have 15. Sorry, let's just move this up because we don't need the rest of this. Right. And then we have 15 times 12 over 11 is equal to X. So that gets the amount of minutes. So 15 times 12, what is that? So that's 10, that's 1, that's 2, that's 30, and that's 0, 1, 5. So that's 180. So X is equal to 180 over 11 minutes. It's not gonna be a perfect number because they're moving at really small like increments, but basically that's the answer. And 180 divided by 11 minutes, that precisely they're gonna form a straight angle because they're opposite they're 30 ticks away from each other. These questions are pretty cool because they like talk about clocks. If you understand how the tick system works, then you're basically fine, which is what I just covered. Now, okay, number 8. In the figure below, A is the center of one of the arcs, and B, CXY is a rectangle. BC are centers of an arc with radius BD and CD, respectively, if the value of the area of the region enclosed by the circular arcs is equal to the value of the perimeter of the same region, determine the length of CD. Okay, so if the value of the area of the enclosed by the circular arcs, so the area of in here, is equal to the value of the perimeter of the same area, so the perimeter, determine the length of CD. So the area of this, let's just say BD is equal to X. So let's kind of draw this out. So we have something like this. You know, this thing is kind of like a circle, and then you have like another circle here, another circle here. Sorry that my picture is not that good. But let's imagine this is X, right? Right, our centers with radius BD and CD. Since technically they said that X and Y and A is a circular arc, technically, then it's gonna be a circle, right? So technically X is equal to X over here. So that's what we know. So since this is a circular, that means this is also X, right? This is the center. So, and this is also X. And then if you make a point here, basically. So the area of this entire shape, which is a rectangle, is either 2x squared. But we need to take out those circles because we only want this part right here. So technically it's just 2x squared minus this is the area of a circle is pi radius squared. So it's pi x squared because our radius is x. And then divide by 4 because it's a fourth of a circle. And then since there's 2 of them, you gotta multiply by 2. So that kind of gets out to, let me move this. That kind of gets out to 2x squared minus pi x over 2. And you could probably just distribute out the x squared. Get 2 minus pi over 2. So that's the area of this part. Now we just need to find the area of the bottom semicircle, which is just x squared. Pi radius squared, so substitute the radius, which is x in there. Since it's half circle, you gotta divide by 2. And you just gotta add that in. So, you have this number added to this number. So this part cancels out with this part. So the area of the thing, it's basically just equal to it's just equal to this area, the 2x squared. Okay. So that would be equal to the perimeter, which is let's say the circumference, which is just 2 pi times radius. The radius is x, so it's 2 pi x. Since there's 2 of them, because there's, oh wait, you gotta divide by 4 because it's a fourth of a circle. And then you times 2 because that's the other side. And then this thing is x 2 pi radius, so it's 2 pi x plus 2 pi x divided by 2 because it's a semicircle. So that gets 2x squared is equal to to simplify this as this 2 cancels with this 2, and this 2 times 2 is 4. So this gets 2 pi x. So subtracting that to the other side, 2x squared minus 2 pi x is equal to 0. So distributing out the 2 and the x, that gets x minus pi is equal to 0. So x can't be 0, okay? Because then x has to equal pi. So the area is just pi. I mean, not the area, the answer is just pi. The value of CD, which is equal to x, is just pi. Okay. Number 9. Using the diagram above, ABE is x degrees. Let's just draw this out again. Okay, ABE is x degrees, and BF and BC is the same. So technically, if this is x degrees, then the other ones have to be the same. So it'll be 180 minus x divided by 2. So this thing is 180 minus x divided by 2. And this thing is also 180 minus x divided by 2. And they say C, G, D is 80 degrees. So over here is 80 degrees. And determine the length of J, D, H. So we need to find this number over here. We'll call it Y. So technically, what we need to do is basically just find this angle right here. And since they're vertical angles, it'll just equal Y. So the value of this angle right here is basically 180 minus x divided by 2 because they're also vertical angles. So 180 minus x divided by 2 plus the 80 degrees plus y, since this is a vertical angle, has to be equal to 180 degrees. Okay? So let's move this up. We just need to do the math now and get it in terms of x. So we have you minus the 80 first, so you get 100 is equal to 180 minus x divided by 2 plus y. And then you kind of minus this, so you get 200 minus the 180, which is 20, and then plus x divided by 2 is equal to y. So our value for J, D, G. Oh, sorry. I was looking at the wrong angle. Oops. Okay, this value is 180 minus x divided by 2, and that was 80. So, JDG, as I said before, since you have a line like this, then x and y, this is x plus y. So you just have 180 minus x divided by 2 plus, basically 80, and you'll get the answer. So that's 160. That gets 340 minus x over 2 is equal to the is equal to angle JDG in terms of x. So that's the answer. You can also simplify this to say 170 minus x divided by 2. The answer is basically still the same. I just prefer to make it all into one. Okay, number 10. Two sides of a triangle measure 5 and 7 units. If all side lengths are integer lengths, what is the probability that the triangle is acute? So, what are the possible measures for a triangle? The two possible measures is the possible measure of for a triangle is basically the two small side lengths add together has to be the two side lengths add together has to be greater than the third side length. So technically, if we have an x side length x, right? Then technically, let's say we have x5 and 7, and then 5x7 and 5, 7x. Like x is smaller than 5 and 7, x is between 5 and 7, and x greater than 5 and 7. Then technically, x plus 5 has to be greater than 7. Has to be greater than 7, so x has to be greater than 2, and x has to be less than 14. I mean 12, because 7 plus 5 is 12. And 12 has to be greater than that. So the numbers have to be between 2 and 12. Move that up. Okay. Now, since it has to be 2 and 12, the only possible numbers is 3, 4, 5, 6, 7, 8, 9, 10, and 11. So those are the only numbers: 3, 4, 5, 6, 7, 8, 9, 10, 11, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of these 9, how many of these make acute? So, the property for acute is basically that if let's say we have two side lengths, right? We have a squared and we have a and b. If a squared plus b squared is greater than c squared, then basically it's gonna be a an acute triangle. So we're gonna have, let's say, if we have 3, right? That's 5, 3, and 7. 7 is 49. So if we have 49 minus 25, which is 5 squared, that's equal to 24. So if it's less than square root 24, because that's the side length for it to be a right triangle, then technically it's gonna be a uh a acute. So square root 24, which so 3 works because 3 squared is 9, 4 squared is 16, and 5 squared that's 25. So wait, 3 squared doesn't work. Wait. Yeah, sorry. 3 squared 3 won't work because that's gonna make a that's too small because I mean it has to be greater than square root 24. So it's 5 works, 6 works, and 7 will work. 4 won't work. Since it's greater than because 8 is greater than 7 now, we're gonna have to recalculate that. So we have 5 squared, which is 25, and 7 squared, which is 49. So we add them together, that is 4, 5, 6, and that's 74. So if, as I said before, a squared plus b squared has to be greater than c squared for it to be an a acute. Technically, if these are 74, which is a squared plus b squared, has to be greater than c squared. So because c squared is the highest. So now that we have that, 8 is 64. 8 squared is 64, so this is gonna be true. So 8 also works. 9, which is 81, which won't work because 74 is greater than 81 is not true. So there's only 4 of them that works. 5, 6, 7, and 9. I mean 5, 6, and 5, 6, 7, and 8. So that's out of the 9, only 4 of them works. So the answer is 4/9. Okay. You just need to know the, your IQ choose him right. Instead, a way to like not memorize it and just think about it is that let's say you have A, B, right, already. Then technically, if you have a side length C, let's say it's in a right triangle, and you have A squared plus B squared. If A squared plus B squared is greater than C squared, that means C has to be like smaller, and it's not gonna connect. So you have this blank amount basically. So if A squared plus B squared, let's say this C, is greater than C squared, right? So it's gonna be smaller. What you have to do is that you gotta move this down for B, so it makes an acute, and that's how I know it's an acute, and that's why I remember about it. Or if you could do it the other way, which is let's say it's something longer, right? And it's C A squared plus B squared is less than C squared, then technically I just need to move B to the other side. So you have B right here, and then it goes like this, right? Because you have to move the B all the way out, so then it can beat the hypotenuse. But you also gotta move the hypotenuse down. So that's how I remember how to like find out if it's a Q obtuse or it's right. Just some tricks, you know. Uh, question 11. Angle, line BD and EF are parallel, and BE and DF is parallel, and DG, DG is perpendicular with FH. Let's draw this out now. So it looks like something like this. And there's another line, and then there's a perpendicular. Okay, so it makes a right angle. So ABE is 60 degrees, so this is 60 degrees, so this is also 60, and this is 60, and this is also 60. Okay. So determine the angle FDG. So we need to find this angle right here, FDG. Since line DG, right, this line right here, basically, is perpendicular, that means it has to make 90 degrees. So since that makes so for 11, since it makes 90 degrees, and this is 70 degrees, I mean this is 60 degrees, so you just have 90 minus 60 equals 30. It's basically just that simple. So angle FDG is just 30 degrees. Number 12. ADEF is a square as shown above, right here. BD are trisection points of AD, and KJ are trisection points of EF, and GHI is divides AF into 4 conjoint parts, and L lies on CJ. Okay, determine the ratio of area AGL to ADEF. So, oh, let's say our length, right? Our length is x for, let's say, for the square, right? And no, let's just use L. So our length is L, and our height is h. So we're gonna have L times h is equal to the area of of the square. So now we need to find the area of the triangle. If you look above it, the triangle only is on line CJ, right? That's what it said on for question 12. That means since it's on CJ, it only goes through A, B, and C. So it seems to like only go on those parts, right? If you think about it, then technically, since it doesn't like because the rest of the triangle does not go to any of CD, so it's gonna go to 2/3 of the length because it only goes through A to B to C. So it only goes to 2/3 of the length. And and for the base, right, which is just A, I, H, and G on the left on that side, right? It's only going through 3 out of the 4, so it only goes through I, H, and G and it doesn't go through F, so it only goes to 3/4 of the height. So the area of a uh of a triangle is basically length. So this is the new length times the new height times 1/2. So we just need to multiply this by 1/2. Right? So that's the area of the triangle. So that will get is equal to 3 cancels with this 3, this 2 cancels with this 2, so this is 1/4 length and height. So the ratio of the triangle of the ratio of the area of the triangle, which is 1/4 LH, the area of the square, which is L times H, just LH, divided by the ratio is just 1/4. The area is just, the ratio is just 1/4 for question 12. It's pretty cool question, but not really difficult. Ln has midpoint M, M, and L, one of the endpoints is 5, 3, and M, which is the midpoint, is 12, 5, 12, -8. Determine the coordinates of N. So this is really simple. What you do is just you write 5 and -3. That's one of the endpoints, and then you write the midpoint, which is 12, -8. So to get from 5 to 12, you just gotta add 7. And from -3 to -5, you just gotta minus 5. So to get the other point, you just do the exact same. So you have to plus 7 to the midpoint and minus 5 from the midpoint. So you get 19, -13. So that's how you get it. 19, -13. That's the answer. And next one. Question 14. The figure to the right has a parameter of 72. Determine the value of x. So we just need to look at all the side lengths. So let's just start on the bottom. So that's x plus 14, right? And now let's look at the left, which is just 2 plus 3 plus 6, right? And now we just need to look at the top, which is 2.5. Actually, we're not going to ignore the proof of fine. Just think of the x, and you're going to move it up. So it's going to account for the 2.5 and like some part up here. So technically, it's just another x plus another and then this starting from this point going here, the side length count for that part of the side length plus the two smaller ones. So that's count for 14, so x plus 14 again. And since this is 6 and this is 3 and this is 2, right? That's going to add up to 9 and 11. That's up to 11. That means the other side length also adds up to 11. Because think about like moving the side lengths to the other side so it looks like a complete rectangle. So that's basically what it looks like. Just because they moved it inside doesn't mean that it's like changed, you know? So imagine you have a rectangle like this, right? And instead they cut the point right here and then they make the line. This is equal to x here, and then let's say this is y and this is equal to y. So technically, instead of that, you could kind of just get this, right? But it's the exact same thing. This x and y. Just imagine moving this out. Well, moving this out. So it's just basically this is the reverse case. You gotta this is basically the same case. You just gotta move the thing out and you'll get the answer. So you have two 11s, because the height is 11 on both sides times 2. So that's 22 plus x plus 14 times 2 from the top and the bottom is equal to the perimeter, which is 72. So this is 22, subtract that, is 50. Divide by 2 is 25, and x is equal to 11. So x, the side length of that side is equal to 11. Okay, number 15. In diagram to the right, determine AB to the nearest tenth. So AB is just 2.5. We just need to find the hypotenuse, so we have 2.5 and 6. So we have 2.5 squared plus 6 squared, and then you have to square root it to find the length of AB. 2.5 squared is just like 25, so 25 squared is just 625, but since there's one decimal point, that means if you have a decimal point and another decimal point, how many amounts are like away to the right of the dot? Basically, it's the amount of space. So there's 2 of them, so you have to find 2 spaces in there. So 1, 2, so it's 6.25 plus 6 squared, which is just 36, right? And you square root it. So that gets a square root of 42.25. So 42.25. I'm guessing it's a number between 6 and 7. So 6 squared is, as I said, it was right here, it's 36. And 7 squared is 49, right? So it's between 6 and 7, right? So what I do is that I usually just choose a number between, so it's, let's say 6.5, right? So now I'm going to test the point for 6.5, because if it's greater than 6.5, right, then if like 6.5 is smaller, is greater than 42.25, right, then basically I just choose a number between 6 and 6.5, so a 6.25. And I just start like going down and down and down until I find out like a good enough approximation. Or if it's like greater than, if 42.25 is greater than 6.5, then I'm just gonna choose between 6.5 and 7. So it's like 6.75. Like just halfway between every single time. And then if it's between that, it'll just be like between 6.5 and 6.75. Maybe I choose like 6.6 or something. And that's what I'll do. So right now I choose 6.5. 6.5 squared is, let's multiply that out. 6.5 times 6.5, that's 25. 2. And that's 30, and that's 32. And then put a 0, that's 30. Put a 3. That's 36, and that's 39. So that gets, you add up to 4, 2, 2, 4. See, now it's equal. So since there's 2 places, that means there's 2 decimal points. So move that here. So it's 42.25. So exactly the same amount. So the answer is 6.5. See, using that method, just go like halfway through and you just get like a good approximation. Number 5. In the figure to the sorry, I already did number 15. Sorry. Number 17. The base of a rectangle is 3 units more than its height. So let's say the base is 3 units more than its height. So its height plus 3, and its height is this, h. if the area of the rectangle is 35 square units, determine the length of the height of the base of the rectangle. So we just need to look for the height. So area is base times height. Substitute the base, which is h plus 3. So h plus 3 times h is equal to the area, which is 35. So that's get h squared plus 3h minus 35 is equal to 0. So we could probably just use the quadratic formula. So let's say, oh, it's 3 more than twice its height. Sorry about that. It's 2h. So it's 3 units more than twice its height. So we have this, and then minus 35. So what I'll do is just put 2h here on one side, and then put h on the other side. So now I have 5 and 7, so minus 10. Okay, so we have plus 5 here and minus 7 here. So because I assume it should always be able to factor out like pretty reasonably. If it doesn't, just use the quadratic formula. But if you just do it this way, it should be fine. It doesn't take that much time anyways. So h can't be negative, so h has to be here. So h has to be 7 over 2. So the height is 7 over 2. Okay, number 17. The area of a trapezoid below is 132 square units. Determine AB. Here, that's 13, and that's 5. And that's 5, and that's also 13. I know the height has to be 12 for the triangle, because this is just a Pythagorean triple. 5 squared plus 12 squared equals 13 squared, so that's 12. So the area of a trapezoid is, let's say this is x and this is x, right? Would just be 10 plus x, which is the bottom base, plus the upper base, which is x, in parentheses, multiplied by the height, divided by 2 is equal to the area, so it's 132. So 12 divided by 2 is 6, and 132 divided by 6 is equal to 222. So 10 plus 2x is 2x plus 10 is equal to 22. So x has to be equal to 22 minus 10 is 12, and 12 divided by 2 is 6. So x is equal to 6. So draw that again. Sorry, it kind of looks bad. So we have 13, 5, 12. This is 6. This is 5. That's 12. And that's 13. And that's 6. So we need to look for AB, which is just 12 squared plus 6 plus 5 squared, basically. So 6 plus 5 squared is 11. 6 plus 5 is 11. So, and then square root it to get the answer. So 12 is 144. 11 is 121. So that is equal to the square root of 265. The answer is 265. Okay, question 18, using this diagram. In triangle ABC, ABD, AB is perpendicular to BD, so this is a right triangle. And angle BCA is 40 degrees. Okay, so let's draw this out. Trying to give myself more room. So this is 40 degrees, and this is 90 degrees, so this has to be 50 degrees. And AC is equal to CE, so this is equal to this one, and which is also equal to DE, which is also equal to this. So determine A, D, B. So we have to look for this. So since these two are the same, right? Since these two are the same, that means it's an isosceles triangle. So this angle is equal to this angle, and this angle has to be 180 minus 2A. So, and this angle, since it's on the opposite side, since it's a line, right? It's just 180 minus A. And then, since this thing is another isosceles triangle right here, basically. It has to be 180 minus that 180 minus A. So that would just be A. So 180 minus 180 minus A. 180 minus A. So the sum of x plus this angle right here has to be A. And since they're isosceles, that means it has to just be A over 2. So technically, sorry, I'm just going to get rid of the x. So this is, let's say this is A, and this is 180 minus 2A. And this is 180 minus A. Then this is A over 2, and this is also A over 2. So we would just use a equation to solve this now. We know the sum of a triangle is 180 degrees, and we already know that this is 90. So we just need to know the other side has to add up to we need to know this one, and this one has to add up to basically 90 degrees. So that is 50 plus A. So 50 plus A has plus plus the other side, which is A over 2, has to equal 90 degrees. So A plus A over 2 is 3A over 2, and 90 minus 50 is 40. So A has to be equal to 80 divided by 3. Right? So the angle of ADB is just A over 2, so just divide A by 2. So 80 over 3 divided by 2, so just put the 2 in the denominator and cancel out. So that's 40 over 3. So the answer for 18 is just 40 over 3. So you need to keep track of your angles for this type of question. It's not really that hard. Okay, in the figure above, center A has an area of 20 pi square units. If the area is inscribed inside a polygon composed of only horizontal and vertical lines, determine the perimeter of the polygon. So the area of a circle is basically pi radius squared. So pi radius squared, which is equal to 20 pi. So you could kind of just cancel out the pi's. So radius is equal to square root 20, which is just 2 square root 5. So that means the diameter is 4 square root 5. If you think about it, it's just if you calculate the left and right side, right? They're basically the same thing, because technically it's just kind of look like a reflection, right? So they're basically the same thing, and the side length of the left and the right is both just equal to the diameter. If you kind of just think about it, because it makes sense, because as I said before in question 14 and 15, which you could just like move the side lengths out, because like they're just moving the side lengths in. So if you just move it back out to make it a perfect rectangle, it's gonna still be the same perimeter. So it's the same case for this one. So technically, if you just move the side lengths out, it's gonna look like a perfect square. So it's just, since each side length is equal to each other, the right, left, up, and down, it's just 4 times the diameter, because the side length is equal to this diameter. So 4 times the diameter, so 4, is 16 square root 5. The answer is just 16 square root 5. Okay, question 20. In the figure above, if one only walks north or east, so it only goes up and right, how many different paths are there from A to B? So let's kind of draw this out. And we have one here, we have one here. Then we draw over here. There's 2 here and 1 here. And we go 1 more down, 1 more, and here. Right? So what you do is that you kind of just think about how many paths. So you're going to count the amount of like intersections. So basically what you're going to do is that how many ways, let's say this A and this B, so you only go up and right. How many ways can you get from here to here? There's only one way, because that's the only way you can move. You only could go right. Right? So how many ways can you get from here to here now, which is also 1? So you just take 2 rights. And how many ways, let me define the A more. Okay. And how many ways can you get from here to here, which is also 1. So this is probably also 1. So so these are also 1 because you just think about it. It's just here to here is also 1. So you just have to move up. That's the only way to get here. So what you do for these is that since these are all 1s, all the outside ones, like for a rectangle, is always 1, or any shape. It's basically just 1. So for intersections, now you look for this intersection, right? So from A to this intersection, it's 2. Because it's just basically this number combined by this number. But you could take one path this way and one path this way, so that adds up to 2. So you kind of just do that the entire time. So how many ways can you get to here? Which is just basically 2 from here, 1 from here, so it's 3 here. So you just add the other intersections from those points to the new point. So this is 3. This is also 3 because this is the only other way to get there. And since they broke off this line, because if they have this line here, this will be 4. But since they broke it off, it's still 3. And you have 3 here and then 1 here, so this one's 4. Alright, sorry. This is 4. And you have 1 path here and 2 paths here, so you have 3 paths here. You have 1 here and 3 here, so that makes 4. You have 1 here and 4 here, that's 5. And this one is also 3 because you can't do anything about it. Like from here, you can only go here, only 1 path, so it's only 1 way. And then you have 3 and 3 here, so this one's 6. You have 3 here and you have 4 here, so you have 7 here. And 7 here and 5 here makes 12. 6 here and 7 here makes 13. And 13 and 12 here makes 25. 4 here and 6 here gets 10. 13 and 10, that's 23. So you have 23 ways to go this way and 25 ways to go this way. So just 25 plus 23 plus 25, which is equal to 48. See? So that's basically how you do it. You just you basically just put 1 for the exterior, and then you just basically count. Don't put 1s here because they're gonna change. So you just put 1s on the bottom and on the left, and then you basically just start adding them together, and then think about it, and then you just like go to B. So the answer is 48. And that basically covers everything for the CCML Geometry Contest 2 2015-2016 Division A. Thanks for watching, and I'll see you at the next math record.